We are going to start a new chapter of chemistry, that is atoms and molecules. Topics involved in this chapter that we are going to discuss here are laws of chemical combination. Then we'll discuss Dalton's atomic theory of matter, atoms, symbols of elements, atomic mass, molecules. We'll discuss chemical formulae, molecular mass and formula mass, ions, valency, gram atomic mass and gram molecular mass, and then mole concept. In the previous chapters, we have learned about matter. As you know, that matter is anything that occupies space and has mass, right? So we know that all the matter is made up of small particles called atoms and molecules, right? And different kinds of atoms and molecules have different properties, due to which different kinds of matter also show different properties, because matter is made of those atoms and molecules. So the properties of matter depend on the properties of atoms and molecules from which it is made. Now, in order to discuss about the laws, first of all, we should know what is chemical reaction. Let's take an example to understand this. Suppose some guests have arrived at your home, and whenever guests arrive, what will we do? Your mama or you will get up and first of all make a tea, right? So what will you do? You will take a vessel with water and boil it, right? And then you will add tea leaves, you will add sugar and milk, and after combining all these substances, tea is prepared and you will serve the tea, right? So all these substances combine, and they will combine. After combining, they will form tea, right? Let's take another example. Let's take how we will prepare curd at your home. You guys know that we'll take lukewarm milk, right? And add curd to it, and then keep it for 4 or 5 hours. We'll get curd. Curd is formed there, right? In both these examples, you can see that some substances are combining and they are forming a new substance. And see, this new substance, whether it's tea or curd, both are having different properties, right, than its constituents. So chemical reaction is nothing but a reaction in which two or more substances react to form products. So it means in a chemical reaction, two or more substances are combining together. They are reacting, and after combination, they are forming a new substance. And that new substance, that new product is having entirely different properties. That is nothing but a chemical reaction. It's so simple. In everyday life, we see a lot of chemical reactions happening around us. These were just two simple examples, right? So it means two substances, suppose substance A and B. They are combining, they are reacting together, and after combination, they will form a product, that is AB. So it means the substances which are taking part in the chemical reaction, which are combining together, they are known as reactants, and the new substance formed is termed as product. Okay. So based on these chemical reactions, based on these changes, that often these changes often occur as a result of combination of two different types of matter. So there are certain rules that govern the combination of different elements to form different compounds. Now these rules are what we call the laws of chemical combination. These are the experimental laws which have been formulated by scientists after performing a large number of experiments involving various types of chemical reactions. And these laws ultimately led us to the idea of atoms being the smallest unit of matter. Okay. So Lavoisier and Proust, they established the laws which explain us a lot about chemical reactions. So there are almost 5 laws of chemical combination, but here we are going to discuss only 2 laws. One is law of conservation of mass, and the other one is law of constant proportion. So let's discuss, let's try to understand what is law of conservation of mass. So what happens in 18th century, scientists noticed that if they carried out a chemical reaction in a closed container, then there was no change of mass. And this preservation of mass in a chemical reaction led to the formulation of the law of conservation of mass. And this law was given by Lavoisier in 1774. And according to this law, matter is neither created nor destroyed in a chemical reaction. It means that the substances, when they are undergoing a chemical change, when the substances are combining, it means reactants are combining, chemical reaction is taking place, then during that reaction, neither mass is created nor destroyed. Yeah, form can get changed. So the law of conservation of mass states that in a chemical reaction, total mass of products is equal to the total mass of reactants. That means there is no change in mass during a chemical reaction. See, if I am taking a substance A and it's combining with substance B, these are reactants. Suppose we are taking 4 grams of A and 6 grams of B. As per this law, it's not possible that this 4 gram gets changed into 6 grams. It's not possible some mass has been added. Or it's not also possible that the 6 gram will become 0 grams. It's not possible that the mass gets destroyed. So what is meant by this, that is meant by this law of conservation of mass. That means there is no gain or there's no loss in mass during a chemical reaction. Mass remains conserved, mass remains constant, and the total mass of products is always equal to the total mass of reactants. See, if I will see the what would be the total mass of reactants, so we will add 4 and 6, we will get 10 grams. It means total mass of reactants is 10 grams. And what is the mass of products here? Again, it's 10 grams. It means mass of reactant is always equal to the mass of product. This is what law of conservation of mass says. Let's take another example. Let's talk about calcium carbonate. See, when calcium carbonate is heated, a chemical reaction takes place, and that chemical reaction is known as decomposition reaction. And it has been found by experiments that if 100 grams of calcium carbonate is heated, it decomposes completely, and after decomposition, 56 grams of calcium oxide is formed and 44 grams of carbon dioxide is formed. Now see, this is the mass of the reactant here is calcium carbonate is the reactant here, and the mass of reactant is 100 grams. Now to verify this law of conservation of mass, total mass of products should also be equal to 100 grams. Now if you add up 56 and 44, you will get 100 grams. Again, and this example shows that the total mass of reactants is always equal to total mass of products during a chemical reaction. Mass remains same, it remains conserved. Okay, so this example supports the law of conservation of mass, right? So now the next law is law of constant proportion. So the law of constant proportion that was given by J.L. Proust in 1779. He basically analyzed the chemical composition of large number of compounds. What is chemical composition? It means the type of elements present in a compound and the percentage of elements present. So he analyzed this composition of different compounds and came to the conclusion that the proportion of each element in a compound is fixed, is constant. And based on these observations, Proust formulated the law of constant proportion. According to the law of constant proportion, in a pure chemical compound, same elements are present in definite proportion by mass and volume, irrespective of the method of preparation. Now, what do we mean by this law? This law means that whatever be the source from which a chemical compound is obtained, or the method by which chemical compound is prepared, a pure chemical compound always made of same elements, and those elements are always present in a compound in the same mass percentage. Now see, let's take an example to understand this, okay? Suppose we are taking water, okay? We are having water. So water is a compound, right? And this water is always made of two elements. Water always consists of two elements, hydrogen and oxygen. Now this law says that in a pure chemical compound, same elements are present always. It means whatever be the source, only those elements are present in that compound, okay? So if we are taking water, whatever be the source of water, always hydrogen and oxygen will be present in water, okay? So this is the same elements are present, right? Now then, elements are present in definite proportion. Now see, if we take the mass of hydrogen, sorry, if we talk about the mass of water, what is the mass of water? Or if we see the mass of water, that means the combination of hydrogen and oxygen. And if we check the proportion of hydrogen and oxygen, see, hydrogen, here are two atoms of hydrogen are present in water compound, right? So mass of one hydrogen atom is 1, but here we are having two atoms of hydrogen, so multiply by 2. Then the mass of oxygen atom is 16, and here it's only one oxygen atom, so we will write 16 here. Now 1 cross 2, that would be 2. 16 is as it is, and when you will do cancellation, you will get 1:8. So the proportion of hydrogen and oxygen is 1:8. It means whatever be the source, if you take pure water from different sources, suppose you take from river, you take from sea or well, always the same masses of hydrogen and oxygen elements are combined to form the water. That means, that proves that the law of constant proportion. That is, this shows that water always consists of the same two elements, hydrogen and oxygen, and these two elements always combine together in the same constant proportion, that is 1:8, okay? If we take the another example, suppose you take the example of ammonia. It's also again a compound, and it's made of nitrogen and hydrogen. And again, if we check the proportion of nitrogen and hydrogen in ammonia, you will again get the same ratio by mass, in fact by volume also. So it means law of constant proportion says that whatever be the source of a compound, same elements are always present and they are combined in a definite proportion. That is what law of conservation constant proportion says.